practical one. Write down determination of determination of acceleration due to gravity. Acceleration due to gravity using simple pendulum. Using simple pendulum. Right. Okay. Listen. What are your names, by the way? Names? New ones, newcomers, names. Dinu T. Hari, list එකේ තිබ්බා. මොනෙත් මා. Nesandu. Desandu. D. All right. Okay, listen. So first write down materials and apparatus. Materials and apparatus. Materials and apparatus. Listen. Right. So first material or the apparatus we need is pendulum. No, pendulum in the sense we have to have a string and a pendulum bob. Right. First, don't write, just look at the board. You have to have a simple pendulum. Don't write, just look at the board. Simple pendulum and a small bob. Right. Now, when you say simple pendulum, there is no, not a must to say a bob separately, right? This is just for your understanding, a small bob and a meter ruler, a stopwatch, and finally, have you heard about corks? What is a cork? C-O-R-K, cork. What is cork? Done on? Bottles වල තියෙන? දන්නවද? අර bottles වල මේ lid එක වෙනුවට එන එකක් තියෙන cork එක කියලා. Cork එකක් ඕනේ. Right? And this cork should be a cork. It should be cut at the middle. Right? I'll explain the reason. A cork cut at the middle. At the middle. Right. This is what we are going to do. Don't write, just look at the board. So you all know what a simple pendulum is, right? So let's say now we have set up this apparatus using the string we have and the small bob, right? And this is a ceiling. Usually this is a ceiling. And when this is fixed to ceiling, we don't use any hooks. The reason is, once the string is fixed using a hook, once it swings, there's a possibility of slipping the string at the hook. No? Can you understand? මෙහෙම hook එකකට අපි string එකක් බැඳලා පස්සේ string එක මෙහෙම යනවනේ. When it swings, there's a possibility of slipping this fixed point. If it slips, oscillations changes. The oscillation is uniform now, right? So therefore, we don't use any hooks. The mechanism here is this. That's why we have a cork, right? Cork එකක් ගන්නවා. Corks දන්නවනේ. What about online students? You all know corks, right? Bottles වල තියෙන. ඔයාලා නම් කොහොමද දැනගන්න ඕනේ? එක එක bottles වල තියෙනවා. විහා මේක ටේබල් එකක් ගහලා දෙන්නකෝ මේ. ටේබල් එකක් ගන්නකෝ name school batch phone number කියලා පොඩි ටේබල් එකක් ගන්න ඊට පස්සේ කට්ටියට ඔක පාස් කරන්න right මේ ඔකට ක්ලාස් එක කට් වුණොත් ඒක ලියන්න with a number right listen hey මොකද කෙසේ හරි හරි ඔක හැමෝටම දෙන්න ඒකද නැද්ද මේ I had only one cup මේ මම මේගොල්ලන් අහගත්තේ මේ තව කප්ස් තියෙනවා නම් ඕක දාලා එයා කරන්න උතන මොකද තේරුණාට චොක්ලට්ස් එකක් තියෙනවා right listen මේ කෝක් එක යූස් කරන්න මේකයි කෝක් is something like this කෝක් කියලා කියන්නේ මෙන්න මෙහෙම එකක් දැකලා නැති අයට මේ බලන්න කෝක්ස් දැකලා නැත්තම් බොටල්ස් දැකලා තියෙනවනේ මෙන්න මෙහෙම එකක් බොටල් එකේ උඩ ගහලා එනවා දැකලා තියෙනවද something like this right that is called the cork right සිංහලෙන් කියන්නේ කිරලැබ කියලා right ඒක because that is made of කිරල right කිරල කියලා පොඩි ගහක් තියෙන දන්නවනේ අන්න ඒකෙන් තමයි හදන්නේ මේ කිරල කියලා රින්ග් එකකුත් තියෙන අන්න ඒකේ ගහ right මේක කියන්නේ කිරලැබ කියලා that is called corks මේකක් ගන්නවා and you have to cut it at the middle right you have to cut it at the middle and what we are doing is this string is passed through the cork like this this is the cork now the cut cork the string is passed through the cork once it passed through the cork a small cut this is a small cut දැන් මෙහෙම එතකොට halves දෙකක් තියෙනවනේ මේක මැද්දෙන් string එක දානවා like this at the moment you can imagine right now the cork is cut into two pieces and the string is put at the middle of the cork like this so then cork එක ඊට පස්සේ මෙහෙමයි තියන්න පුළුවන් එක දාලා the purpose is now this fixed point is actually a fixed point no slipping because a small cut is only a small cut has to go the string පොඩි string එකක් නේ දාන්න තියෙන්නේ string එක දාන්න විතරක් cut එකක් දාගෙන තියෙන්නේ තොර hook එකක් use කරන්න බෑනේ දැන් hook එක මෙතන තිබ්බට අවුලක් නැහැ right එතකොට මෙතනනේ fixed point එක that's the purpose of using a cork a cut cork right all right and this is the bob pendulum bob and the next thing is I didn't mention here we have to have a locating pin or we can say a reference pin listen a locating pin or a reference pin the purpose is ඒක දැකලා තියෙනවනේ it's kind of a needle පොඩි needle එකක් වගේ පොඩි එකක් reference pin or the locating pin right the reason is now we are going to count oscillations here you are going to count oscillations number of oscillations so therefore you have to have a fixed point to count it when passing no that fixed point is called the locating pin right and we place the locating pin there are two possible places actually there are two possible locations that we can do right either at the lowest point of the path there is one possible way or can be placed at here right now for the diagram I will draw it here and in the latter part I'll explain the difference between placing this here and here right දෙකම කරන්න පුළුවන් බැරි නෑ දෙකම කරන්න පුළුවන් there are differences right all right one more second right now what we are going to do here is something like this so we know we have already proved one equation for period of a simple pendulum in simple harmonic motion right that is a proved equation but that is only valid for simple harmonic motion to be this motion simple harmonic it is valid only for small angles small oscillations right otherwise it is going to be a circular motion right so therefore we have to make sure that you are going to swing this oscillate this in small angles as values right this should be less than 6 degrees like 5 to 6 less than 6 maximum less than 6 degrees maximum right and we know period of a simple pendulum in simple harmonic motion is what's the equation that's a known equation t equals 2 pi root L over G no right and what is L here and what is G here L is very special here what is L here length of no not length of string what is L here class එකේ කියලා දෙනවා හොඳලා. and discussions වලත් කියලා දෙනවා. මේ week එකේ තිබ්බ paper එකෙත් මේකෙන් ගානක් තිබ්බා. Huh? What is it? What is it? Length from attached point to or fixed point to center of gravity of the bob. Not the string, center of gravity of the bob. Right? So very important. Otherwise, this is not the length. This is not the length. Right? It should be measured from here to the center of gravity. Right? Usually we are using a spherical bob. So it should be the center of the bob. Right? This is the length from fixed point to attached point to center of gravity of bob. Center of gravity of bob. And what is G? G is also not gravitational acceleration. It is gravitational acceleration if and only if the system is at rest. If not, that is about resultant acceleration. Right? Questions? Otherwise, there is resultant acceleration. Right? If the pendulum was fixed inside an elevator, moving elevator, or a moving bus, moving car, something like that, resultant acceleration comes. Right? So therefore, even though we are writing G here, G is if and only if this ceiling is at rest. This system is at rest. If the system moves as a whole, it changes. Right? So therefore, this is actually resultant acceleration. Resultant acceleration. And that is gravitational acceleration if the system is at rest. Right? Now here our system is at rest, no? This fixed was ceiling. Right? Ceiling or make a stand එක ඕන fix කරන්න පුළුවන්. A fixed stand එක දාන්නත් පුළුවන්. ප්‍රශ්න නැහැ. Right? So therefore, for our thing, we will be using G. But you have to know that G is not gravitational acceleration, that is resultant acceleration. Right? So wherever it is applicable, you have to use the resultant acceleration. Right? Okay, ගණන් තියෙනවා. කරලා තියෙනවා. මම ක්ලාස් එක කරා. All right. Now, what we are going to do is something like this. We are going to determine acceleration due to gravity, no? Which means G. Now, since T equals 2 pi root L over G, T squared equals 4 pi squared L over G, no? Right? Now, from these variables, what we can change here is, what we call that variable that we are changing? What's the name? Changing variable. Independent or dependent? Independent. Right? X. So therefore, only possible variable to change here by ourselves is L. Time එක change කරන්න බෑනේ. If L changes, only time changes. Right? ඔක්කොම වලින් time එක change කරලා length එක change වෙන්නේ නැහැනේ. Right? So therefore, only possible variable to change here manually is L. That is what we are going to do. So therefore, we are going to change L. And when L changes, accordingly, T changes, no? Because 4 pi squared is a constant, G is a constant. When L changes, accordingly, T squared changes. Right? So therefore, when L is the independent variable, T squared becomes the dependent variable. Right? Considering that, we can rearrange the graph, rearrange the equation actually, like this to plot a graph. Now, if we plot a graph between these two, considering whole T squared as y and L as x, right? Whatever it is as a product with x is m, right? We should get a y equals mx curve, T squared and L. We should get a y equals mx curve, right? A straight line goes through origin. And gradient of that gives 4 pi squared over g, no? If gradient of this graph is, see, if gradient, say m of the graph is, these are numerical value, no? Once the graph is down, it is 4 pi squared over g. Now our target is determining g. Right? If gradient is known, m equals 4 pi squared over g, so g is given by 4 pi squared over m. Right? G is given by 4 pi squared over m. Right? Which means now our target is this. after conducting the experiment, listen, after conducting the experiment, our target is we are going to have 6 pairs of values for L and T squared. Right? Once we have minimum 6 pairs of values for L and T squared, you can plot the graph. Once the graph is plotted, you can determine the gradient using the graph. If the graph is there, we know gradient is standard. If the graph is there, so using the graph, you can determine gradient. From the graph, gradient is a numerical value. From the equation, gradient is 4 pi squared over g. Equate those two, and g is 4 pi squared over m. Right? So that's basically what we are going to do. Right? Is it clear? Clear? Right. Now write down. Write down materials and apparatus. So here basically I have explained everything. There are more things. I mean, basically this is what we are trying to do. We are going to do in this experiment. Huh? මේක මේ කොලම් එක දාන්න මේක අහන්න මේක හෙඩ් එකකට දාපන් මම හතරක් කිව්වේ නැද්ද හතරක් කිව්වේ නේ කොලම් හතරක් ඕනේ කියලා මම කිව්වේ නේ මම කිව්වා හතරක් ඕනේ කියලා ඔය සෙට් එකෙන් අහලා වැඩක් නැහැ වෙන කායෙන් හරි මම කොලම් හතරක් ඕනේ කියලා කිව්වේ නේ හතරක් ඕනේ හතරක් ඕනේ name මොනවද මම කිව්වේ school batch phone number නෑ නෑ write down materials and apparatus write down one by one materials and apparatus write down one by one first a simple pendulum write down a simple pendulum a simple pendulum a simple pendulum oscillating length okay a simple pendulum a small bob within brackets metallic there are reasons we'll explain in the latter part why we need to stick to a metallic one rather than using a wooden or something else right there are reasons so in physics for anything there's a justification no for here so that's there a small bob metallic is preferred no? Metallic then a meter ruler why we need a meter ruler why do we need a meter ruler now we are going to change length then we should be able to measure the length of the string right from here to the center of the bob a meter ruler is needed right a meter ruler then a stopwatch why a stopwatch we need to measure t squared periodic time right we have to measure t once t is measured only you can find t squared right a stopwatch next one you better write this with a red pen this one cork cut at the middle cork cut vertically cork cut vertically at the middle cork cut vertically at the middle a small cut just to penetrate this string just to put the string that's it right a cork cut vertically at the middle 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 last one locating pin a locating pin a locating pin right okay then take this down as the theory oh wait so before the theory you have to draw this here materials and apparatus Draw the apparatus, only the apparatus, this part. Draw this, and this is the locating pin, and label these ones. Draw the diagram only, right? Locating pin, bob, this is the string, cork, right? Take it down. And let me mark L here. You also have to mark this L to the center point, up to the center. That is very important. Take down the apparatus. Adisa, put video clips take a karangoni. Eda lasan daranti be eda adisa lasan ya karanti bang dalib. Me nana කීපයක් ගන්න වෙයි මේ එකම ඇන්ගල් එක තිබ්බට පස්සේ එඩිට් කරද්දී මේ එකම ඇන්ගල් එකනේ ඇන්ගල්ස් කීපයකින් ගමු මේ ඔයාගේ ෆෝන් එකෙන්ම ගන්න ඒකේ සෑහෙන්න වෙනසක් තියෙනවා 13 එකත් එක්ක 13 ඒ කියන්නේ මේ ඒක රෝ නෙමෙයි මගේ එකේ රෝ ෆෝමැට් එකක් තියෙන්නේ ඒ වුණාට අරක ලේසි just randoms අර එදා වගේ එහෙම මොකුත් නැහැ randoms ඔය ටික කොහොමද less than 1 minute මේකක් නේ යන්නේ හැදෙන්නේ පොඩි පොඩි ඒවා ටිකක් තිබ්බ නෑ නෑ charge වුණාට පස්සේ අය නම ඇවිත් බස් එක යනද නෑ මේ ආයි මං පස්සේ ඕන්න දෙන්නම් මට පොඩි ක්ලිප්ස් දෙක තුනක් ඔය පැත්තට තරම් දෙන්න angles පොඩ්ඩක් වෙනස් වෙන ක්ලිප්ස් එක right sorry I was muted fine no sorry I was muted right take down this as a theory write down the equation T equals 2 pi root L over G and L is length from attached point to center of gravity of bob this is very important to the center of gravity of bob and G resultant acceleration right 1 2 3 4 කියලා දාලා Pascal resultant acceleration right resultant acceleration within brackets, gravitational acceleration within brackets, gravitational acceleration is applicable. Gravitational acceleration is applicable only if gravitational acceleration is applicable only if the system is at rest. Gravitational acceleration is applicable only if the system is at rest. Gravitational acceleration is applicable only if the system is at rest. Right? Okay. Then write down. Now the equation is done. Here, somewhere here, put a point and write down. Right? Put a point and write down. If oscillating length, write down. If oscillating length is simple L and period of oscillation is capital T, and period of oscillation is capital T. Put a comma and write down the equation again. T equals 2 pi root L over G. Write down the equation again. T equals 2 pi root L over G. And then consider the square of both sides and write all lines up to here. Y equals mx. Up to here, y equals mx. Right? And now plot the expected variation between t squared and L. We are going to consider t squared as y, L as x. Then it is going to be a y equals mx variation. That is a straight line which goes through origin. Right? And mention these things. Gradient equals this. So G is 4 pi squared over M is gradient here. I have introduced it here. Not a mass. That's a gradient. Here. Paste. Write down below with an asterisk mark. Write down below. Write down. Since gradient of graph is known, within bracket simple M is known, since gradient of graph within brackets simple M is known, since gradient of graph within brackets simple M is known, simple M is known, G can be determined. G can be determined. Right. Okay. Now let's see all the steps that we are performing from the beginning. Right. So put a subheading as method. Put a subheading as method. 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 Right. First point. First point. Write down. Put the string of. Put the string of. Put the string of. Put the string of simple pendulum. Put the string of simple pendulum through the cut of cork. Through the cut in cork. Through the cut in cork. Through the cut in cork. And suspend it. And suspend it. On a ceiling or supporter. On a ceiling or supporter. And suspend it on a ceiling. On a ceiling or supporter. On a ceiling or supporter. Second point. Write these ones in point form. In point form. Second point. Second point. Measure the distance from. Measure the distance from attach point to center of the spherical bob. Attach point to center of the spherical bob. Attach point to center of the spherical bob. Right. Next point. Next point. Keep the locating pin. Keep the locating pin. Keep the locating pin close to. Keep the locating pin close to the lowest point of path of simple pendulum. Close to the closest point, lowest point. Keep the locating pin close to the lowest point. Keep the locating pin close to the lowest point of path of simple pendulum. Next point. Swing the bob with a small angle. Swing the bob with a small angle. With a small angle. Swing the bob with a small angle. Within brackets. Within brackets. Less than 6 degrees. Right? Maximum 6. 5 වගේ පුළුවන් නම් තව හොඳයි. Right? 5 වගේ පුළුවන් නම් තව හොඳයි. The constraint is this. Listen, constraint is this. Once the angle is decreased, the time it takes for one oscillation, what happens? If the angle is small, right? So therefore, we have to count more number of oscillations if the angle is too small. And since there's a damping here, there are two constraints. Make a dampen on, right? The amplitude decreases over time because we are doing this in reality with the air drag. Right? Oscillate it is not going to swing forever. Right? It is going to damp the oscillation. So if there is a small angle, it is going to damp quickly. Right? So therefore, maximum we can go up to 6 degrees, not more than that. Right? 5 to 6 mainly maximum 6. Within brackets, less than 6 degrees. Right. Next point. Listen. Now, listen, before the next point, you are not going to measure the time for a single oscillation, right? For a single oscillation. The reason is this. Usually, what we have in our labs as stopwatches are the stopwatches with least count. What's the least count of the usual stopwatch we have in the, I mean, typical one we have in the lab? 1 millisecond, right? 1 millisecond එක නෙමෙයි usual එක. 1 millisecond එක තියෙනවා. 1 millisecond එක නෙමෙයි usual එක. ගොඩක් schools වල. 0.1 seconds. Right? 0.1 seconds එක තමයි, I mean, the popular one. The popular and typical one is this. This is the typical one. Right? 1 millisecond තියෙනවද? තියෙනවා. The typical one, if you have the manual one, digital එකේ අරක normal, right? The manual stopwatch එක තියෙන ඒවා තියෙනවා නම් තාම එහෙම use කරන කට්ටිය ඉන්නවනේ තාම. ඒ කියන්නේ තාම schools වල තියෙනවා. මම හිතන්නේ ඕනි ස්කෝල් එකේ තියෙනවා. දෙකම ඇති. manual and digital දෙකම තියෙනවා තාම. දන්නේ නැහැ ලැබ් එකට ගිහින් නැහැ. manual එකේ කට්ට දුවන එකක් තියෙන්නේ. gauge එකක් දුවන එකක් තියෙන්නේ. කට්ටක් යන්නේ. අන්න ඒකේ point one තමයි ගොඩක් වෙලාවට තියෙන්නේ. Right? So therefore in a typical one, listen. In the typical one, there is 0.1 seconds. So therefore, you have to have a reading which doesn't exceed our maximum percentage error. What is the maximum percentage error allowed in our experiments? That I have explained before. 1%, only 1%, right? So therefore, you can do a calculation, a reverse calculation, and come up with the minimum number of oscillations we need to get the error which is less than, it should be less than 1%. Because if the error is less than 1% now, as an example, what is the equation of percentage error? Percentage error equals, please count over reading into 100%. Percentage error, right? Now, maximum percentage error we are allowed to have is 1%, right? And let's say least count of the instrument to use is 0.1. 0.1. අපි නිකන් මෙතනට එන reading එක බලමු. See, now reading is 10 seconds. Reading is going to be 10 seconds. So therefore, listen, you have to choose a possible number of, a required number of oscillations as to exceed 10 seconds. Then 10 වලට වඩා අඩු reading එකක් ගත්තොත් the error is going to increase, or පේන board error is going to increase 1%. Right? So therefore, just to have 1%, the time duration, time interval you should take is 10 seconds. Right? Then you have to decide whether it's 20 oscillations or 25 oscillations or 50 oscillations based on the time it takes for one oscillation in your experiment, right? Generally, we say it's 25 because generally you are starting this length from 40. That's why you can 40 වලට length එක අරගෙන 6 කියන degrees, 6 degrees angle එකෙන් oscillate කරොත් සාමාන්‍යයෙන් 25 oscillations යන 14 seconds වගේ යනවා. So therefore it says 25 generally, right? But there's no rule to start from 40. So ආගේ bob එක වෙන setup එකක් වෙන්න පුළුවන්. So therefore the best option is we can't stick to 25 and we don't need to. You don't need to. 25 කියලා එක rule එකක් නෙමෙයිනේ. You don't need to. Right? මේක තමයි මේකේ තියෙන argument එක. This is the logic behind this. Our percentage error should be less than 1%. So therefore, the reading you are going to take from the stopwatch should be greater than 10 seconds. It should be greater than 10 seconds. To have 10 seconds, you can decide whether you are going to count 20 oscillations or 25 or 30 or 35, whatever it is, as to have a reading which is greater than 10 seconds. Is that clear? හරිනේ? දැන් මේක පාඩම් කරගන්න ඕන එකක් නෙමෙයි. මේක logical. මේක logic එකක් තියෙනවා. එහෙම තමයි ඒක decide කරන්නේ. නැතුව හැමෝගෙම bob එක මේ 25 වලට යන්න එහෙම set වෙන්නේ නැහැ මොකද? එහෙම වෙන්නේ නැහැ. Generally, that's a general value. Right? මේක තමයි මේකේ behind තියෙන්නේ. All right, next point. Now write down the next point. Next point. Decide number of oscillations to count. Decide number of oscillations to count. Decide number of oscillations to count. Decide number of oscillations to count as not to exceed percentage error. Sorry, not to exceed 1%. Not to exceed 1% by the percentage error. As not to exceed 1% by the percentage error. And show this example calculation here. Show this example calculation. And now this changes if your stopwatch is having a least count which is different from this. මම මේ කරලා පෙන්නුවේ if my stopwatch has a release count of 0.1 seconds, right? ඊට වඩා අඩු එකක් තියෙන watch එකක් නම් ඒකට respectively වාගේ value එක වල හොයා ගන්න පුළුවන්. That's why මේ කියන්නේ. නැත්නම් දැන් guide එකේ දාලා තියෙන 25 oscillations කියලා ගෙලින්ම දාලා තියෙනවනේ 25 හරි 20 හරි කියලා. ඔක බලන්න 25, right? 25 කියලා දාලා තියෙනවනේ. ඒක general value එකක්. not a rule, right? මේක තමයි logic එක. And for that above point, within brackets, write down for that above point, within brackets mention generally 25 oscillations are considered. Generally 25 oscillations are considered. Generally 25 oscillations are considered, right? Next point, we are still under the method. Next point, measure time, it takes for 25 oscillations. දැන් ඔය general value එක මම ඉතින් ඉහළ mention කරන්නේ මම logic එක කිව්වනේ. Measure the time it takes for 25 oscillations. Within brackets, write down usually 2 time readings are taken. Usually 2 time readings are taken and average is considered. Usually 2 time readings are taken and the average is considered. Usually 2 time readings are taken and the average is considered. 2 time readings are taken and the average is considered. Right? That is something we do for more accuracy. Right? Readings දෙකක් අරගෙන average කරනකොට the error is less, no? Right? Personal error, human error. Personal means human error. Right? පොඩි හරි දැන් මෙයා pass වෙද්දී අපි count එක ගන්නවා. Right? We are taking the count when it passes the locating pin like this. Right? හරි පොඩි හරි delay එකක් වුණොත් it will be average. ඒක අර mean value එකක් වෙලා යනවනේ, average වෙලා යනවනේ when you consider the average. So that's why only 2 are considered. If you can consider more than 2 readings for a given length and take the average, accuracy of the experiment can be increased. 3ක් අරගෙන 3 average එක ගත්තොත් තව accuracy වැඩි. ඒක තේරෙනවද? 4ක් අරගෙන ගත්තොත් ඊට වඩා වැඩි. Right. Next point. Repeat the experiment. Repeat the experiment for minimum 6 different values, of length, for different 6 minimum values of length and record obtain readings in the following table. Obtain readings in the following table. Right. See? So this is the data table. Look at here. This is L. We measure L in centimeters, right? And this is T. We measure T in seconds. And we have to take 2 readings now, right? This is the reading 1 of time, reading 2 of time, and reading 1 and 2, and final T. This is the average, and one more column for T square. This is in seconds, and t squared is in s squared, right? And you have to have 6 readings minimum, right? So this is the data table. 6 readings minimum. එවලනේ නිරායි ඔය උඹට නෑ ඉතින් දාලා නේද මේ ගිය සතියේ මොකද ශෝක සතිය ඇඬුවා ඇඬුවේ මේ හෙට බනද නෑ යනවා හරි 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 take this down මම මෙතන values දාන්නම්. Usually we are starting from 40 and increasing the length. Listen. Usually we are starting from 40, right? Usually starting from 40 and increasing the length 10 by 10, right? 10 centimeters by 10 centimeters. So මෙහෙම readings එකක් එන්නේ 40, 50, 60, 70, 80, 90, right? Then corresponding times are here, right? For a given length, you are taking 2 readings, right? 2 readings for a given length and get the average here. This T here is the average. I mentioned the average here. This is the average. My mention kanan T average periodic time. Average periodic time. Average periodic time. Average periodic time. Alright, take it down. 17 my darling 17 17 yeah what a 50% 80 මට different angles එකක් ඕනේ. අරගෙන ආයි විහංග වගේ විහංග හරි මෙහා හරි වගේ දැන් එකම වීඩියෝ එකක්. Right. Finished? හරිද? I need randoms අද හරිද? Finished? මේක mention කරන්න T is average periodic time because you have 2 readings here, right? Reading 1, reading 2, something like this. Reading 1, reading 2, and the average here. Average is R1 plus R2 over 2, something like this. And the square value of that. Squared value of that. හරිනේ වැඩේ තේරෙනවද? Yeah. No. In a free time. හරිද? And write down next point. මේ තාම method එකේ ඉන්නේ. We are still under the method. Plot T squared against L. Next point. Plot T squared against L. Plot T squared against L. Plot T squared against L. Last point. Calculate gradient of graph. Calculate gradient of graph. Calculate gradient of graph. And determine G as discussed under theory. 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 Right? Under theory again, mega. Using this. If gradient is known, G is given by 4 phi squared over M. Right? Phi is a known value. 2207. Right? Not 3.14. 3.14 daan. What's the reason? That is not an ending decimal. That's the thing. Right? 3.14. Haven't you seen a video of Dr. Pantaleon? He is finding it up to 1000 decimals. The video වල තියෙන කවුරු ඉන්නවද? කම්බයින් මැත්ස් කරන සෑහෙන කෙනෙක් පැන්ටලියන් කියලා. දන්නේ? පස්සේ බලන්න. එයා වෙනම ලෙවල් එකක ඒ කියන්නේ එයාගේ මැත් ස්කිල්ස් මාර ලෙවල් එකක තියෙන්නේ. ඉතින් හොයන්නේ. for up to 1000 decimals. බලන්න නැත්තම් බලන්න. right? දන්න? කවුරුද දන්නේ නැද්ද? කවුරුද දන්නේ? right. මේ තාම ක්ලාස් එකක් කරනවා එයා. ඇත්තට? ඒ කියන්නේ 1000 ගිහිල්ලා there's no any pattern up until 1000 decimals in 5. මේ 5 කියන්නේ මාර වැලියු එකක්. කියන්නේ සමහර අය වගේ අර වැලියු සෙට් එකක් ඇවිල්ලා ඒ සෙට් එක රිපීට් වෙනවා. ඔය නම්බර්ස් ගහද්දි තේරෙයි. නිකන් මම නිකන් නම්බර් එකක් කියන්නම්. 1/29 කියන්නකො. 1/29 කැල්ලයක් ගැව්වොත් decimals 28ක් විතර ගිහිල්ලා ඕක රිපීට් වෙනවා. ඒ කියන්නේ මේ 28 ආපු ටිකම තමයි ඊළඟ 28 එන්නේ. ඒකම ඊළඟ 28 එන්නේ. එහෙම ඒක රිපීට් වෙනවා. හැබැයි 5 ගේ එහෙම කිසිම පැටර්න් එකක් නැහැ. ඒක මාර නම්බර් එකක්. right කොහොම හරි. so therefore we don't apply මම කියන්න ගත්ත එක මේකේ point එක we don't apply 3.14 14 නෙමෙයිනේ ඒක. ඒක තව යනවා. but if you apply 22/7 we are safe because that is considered. so through decimals එක තියෙනවනේ it is inside 22/7 no. right? 22/7 දැම්මා 4 5 squared over m gives gradient. gives gradient නෙමෙයි g. gives g. right? over gradient. මේ තියෙන gradient එක. right? is it clear? Any questions? So that's all about the experiment. Right? There are few more important things to be discussed. So before that, any questions about the experiment? Any questions about the experiment? Online? Any questions? All good? Dinu kane? This one. Dinuti. Onetma. Huh? Onetmi. අනිත් අය නම් දන්න කට්ටියනේ මේ. තව ටිකකින් මට මතක හිටිනවා. Any questions? Online students? Quickly. Any questions? Any questions? Quickly. Any questions? All good? All good? Online? No. Clear? Right. Okay then. Now, the next thing is other important things about this important things. මේ ටික ගයිඩ් එකේ කොහොමත් නැහැ මොකද? listen. මේ මම දැන් එක්ස්ප්ලেইন කරපු ටිකත් ගයිඩ් එකේ මෙච්චර හොඳ නැහැ. දන්නවනේ. ඔක බලද්දි තේරෙයි. මේ මම මෙහෙමයි. listen. So once we finish discussing the experiment, the whole thing, you can go through what is given in the guide. එතකොට ඒක හොඳට තේරෙයි. මේක දන්නවා නම් ඒක ඇති දෙයක් නෑ. right? අපි බලමු මාත් go through කරලා බලන්න. මේ explain කරලා පස්සේ නිකන් බලන්න මොනවද ඒකේ තියෙන්නේ කියලා. right? ඔය තියෙන guide එකේ තියෙන ටික. right? and දැන් කියන්න හදන්නේ these are the important things to be considered when conducting the experiment. right? Put as remarks. Remarks. and write down one by one. 3 marks. Remarks. First point, write down one by one. First point, following conditions should be satisfied. 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 First point, following conditions should be satisfied for the validity of equation, this t equals 25 root L over G. For the validity of equation t equals 25 root L over G. Right? Under that main point, right? First bullet point. මේ conditions තුන කියන්නේ. Conditions තුනක් තියෙනවා. මේ conditions තුන කියන්නේ. First one, only for small angles. Only for small angles. මම කලිනුත් mention කරා. මේ ආයි mention කරන්නේ මෙතන remarks ටික තමයි. These are the most important things you need to know about the experiment to conduct the experiment without errors. Right? දැන් කරාට පස්සේ G වලට 60ක් විතර එනවා. අවුල්නේ. එහෙම වෙනවා ඉතින්. දැන් සමහරුන් දන්නේ නැතුව කරනවා. දන්නේ නැතුව කියන්නේ නිකන් අර oscillations හරියට ගන්න නැතුව එක ප්‍රශ්න ඉතින්. දැන් මෙතන මේ ටික කිව්වට පස්සේ තේරෙයි මොනවද වෙන්න පුළුවන් mistakes කියලා. ඉතින් මේ mistakes කරොත් you can end up having an impossible value for G. Should be something around 10, right? When you are finding 9.81, it is fine if you got 9.5 or 9.3, something like that. Like apart out them around 25, 30, okay, value impossible to have. Mistake right? First one, only for small angles. Second bullet point. Air resistance on bob. Air resistance on bob should be negligible. Air resistance on bob should be negligible. Next one. Bob should not be rotated or rotating. Bob should not be rotating. Bob should not be rotating. Bob should not be rotating. Right? Rotating කියලා කියන්නේ this is fixed to a string no. තර දැන් වා මේක swing කරද්දි oscillations කරද්දි මෙහෙම වෙවි bob එක යන්න බෑ. bob එක rotate වෙන්න පුළුවන් නේ with the string. අපි කියන්නේ තන්තු මේ ඇම්බර් වෙනවා කියලා. ඇම්බර් වෙන්න පුළුවන් ඒක rotate වෙනවා. rotate වුණොත් එහම අරක ඇම්බර් වෙනවා. එතකොට තව කතාවක්. එතකොට elastic potential energy එකකුත් වගේ මේ deposit මේ store වෙනවා. ඊට පස්සේ මේක කොහොමද එතකොට valid නෑ. right? Bob should not be rotating. කරකවන නම් මම මොකුත් බෑ. අපි නිකන් මේක මෙහෙම උඩට කරලා අතරින් එක විතරයි කරන්නේ. right? You can take it somewhere here and you are going to release. right? එතකොට මෙහෙම ගහන්නේ එහෙම නෑ ඔය. මේ shape එක මෙහෙම පොඩි angle එකකට අරගෙන අතරින්. right? okay, next point. තර මේ වගේ next main point, second point. A string is not fixed to a hook at the top. A string is not fixed to a hook at the top. Okay, clear? A string is not fixed to a hook at the top. A string is not fixed to a hook at the top. Because it can slip at the hook it can slip. It can slip at the hook. It can slip at the hook. It can slip, slip at the hook when oscillating. It can slip at the hook when oscillating. For the same point, therefore, a cork with a vertical cut is used. Therefore, a cork with a vertical cut. A cork with a vertical cut is used. Therefore, a cork with a vertical cut is used. Next point. Period is not taken. Period is not taken. Next point. Period is not taken only for one oscillation. Period is not taken only for. Period is not taken only for one oscillation. Period is not taken only for one oscillation. Period is not taken only for one oscillation. What's the reason? What's the reason? Percentage error. Percentage error will go beyond 1%. Right? Like oscillation right? Low percentage error 10%, 12% percentage error. Right? So that's why 20, 25, 30, 50 right? General value 25. Within brackets. A suitable number of oscillations should be considered. A suitable number of oscillations should be considered. A suitable number of oscillations should be considered. A suitable number of oscillations should be considered as to maintain percentage error below 1%. As to maintain percentage error below 1%. As to maintain percentage error below 1%. Right? For the same one, generally 25 oscillations. For the same point, generally 25 oscillations. Generally 25 oscillations. Next point. Angle of oscillation should be less than 6 degrees. Right? Next point. As the point write down, fixing locating pin. Fixing locating pin. Right. See. Now this is a magnified view of the bob. Right? A magnified view of the bob. Say A, B, C, D, E. We have some points like this. Right? Then ප්‍රශ්න වලට එද්දි මේ වගේ වහන ඕනේ. එහෙම තමයි. Right? ප්‍රශ්න වල අහනවා why it is not suitable to fix locating pin at E. එහෙම අහනවා. එතකොට ඉතින් ඔයා හරියට answer දෙන්න. Right? නැත්නම් ඔය අනිත් පැත්ත. Why it is suitable to fix it at the lowest point of the path. Right? There should be a reason, no? So there are reasons. Right? So let's see one by one. If you consider a point like A. If you consider a point like A, right? If you consider a point like A, what happens is, now when this oscillates, like this, it damps over time. No? When it damps, it won't reach point A over time. It damps. මුලින්ම A වලට it damps no. Damping කියන එක දන්නවනේ. Amplitude decreases over time. Amplitude decreases. ඊට පස්සේ මේක A වලට එන්නේ. Right? එතකොට ඉතින් මෙතන count කරන්න බෑ. So therefore, a point like A is not suitable. Right? The reason is මම මේ ටික reasons ඔක්කොම කියනවා. Right? මේක එක points ඔයාගෙන් අහන්න පුළුවන්ද? එහෙම questions ඕන තරම් ඇවිල්ලා තියෙනවා. ඒක දැනගෙන ඉන්න ඕනේ. Suitable points මොනවාද? Not suitable points මොනවාද? With reasons. With reasons. Right? A is not suitable because when the oscillating damps over time, it won't reach point A. Right? So 25 ගන්නකොට පළවෙනි පහේ විතර ඔන්න A වලට එයි. පස්සේ එන්නේ නැහැ. එතකොට ඉතින් pin එක move කරන්න බෑ. Right? What about a point like point B? Point B එකට fix කරන්න මෙහෙමයි. නැද්ද මොකුත් swing කරන්න පුළුවන් එක? ඈ? නෑ charger එක අපරාධනේ charger එක වගේ ගන්න නැහැ මොකද? නෑනේ. පොඩි charger එක. තියන? නෑ මොකද? කරේ කතාවක් කිව්වද? හරි. මොකුත් නෑ imagine කරගන්න. මේ නෑ මේකේ මේ බොබ් එකක් නෑ බොබ් එකක් තිබ්බනම් හරි. අර පොඩි ඇඩැප්ටර් එක නෑ පොඩි ඇඩැප්ටර් එක නැද්ද? මගේ ලොගෝ එක තියෙන. හරි. එහෙම කියන්නකෝ. මොකද? type C ද? නෑ මේක lightning type C කියවලද? නෑ මේකද lightning තියෙනවා. මේ type C තියෙනවා. මේකද? මුලින් දෙන්න තිබ්බේ. Okay, look at here. We got a bob. හරි. දැන් මෙහෙම තියෙනවනේ. හරි. This is the pendulum we have. pendulum එක මෙහෙම දැන් යනවා. Right? B locate කරනවා මෙහෙම. මේ බලන්න මේක damping එක. මේ. දැන් මම මේක මෙහෙම කරනවා අතින් හොඳේ. නැත්තම් damp වෙනවා. ඒ කියන්නේ මේක string එකක් නෙමෙයිනේ. These are thick wire. එකක් ගාලා damp වෙනවා. නේ? It damps. එකක් ගාලා damp වෙනවා. 25 oscillations යන්නේ නැහැ මේක. Right? So that's why we use a thin string. If you are locating pin at B, this is how we should place. So you are doing the experiment, you are checking this from the front side. So make a pair on make a pass point. This is point B. This is point B. Point A point A point A. හරිනේ මම පොයින්ට්ස් එක ඔක්කොම පෙන්නන්නම් C කියන්නේ C වල තියන්න බෑ it collides C කියන්නේ මේ center point එක C වල තියන්න බෑ right දැන් C වල ඕන මෙහෙම කෙනෙක්ට තියන්න පුළුවන් just behind this then the thing is the locating pin is going to be covered by the bob දැන් cover වෙනවා නම් පේන්නේ නැහැ count එකක් ගන්න බෑ that is not a fixed point right ඊට පස්සේ මෙතන තියන්න පුළුවන් like this like D වගේ or E කියන්නේ මේ වගේ right. Okay, now tell me, what about B? Make a Honda point at the I mean, whether it's suitable or not suitable. B is a suitable point. B will die among Kalinga in again. Right? B is a suitable point. And for a spherical bob, B is actually the most suitable point. Haridama may point may point easily balana lazy. I metame Vayaga, Mega, Dekama, Yana point at me. So therefore, when you are doing this practically, right? When you are doing this practically, checking point B is kind of easier compared to D, right? Both B and D are workable, right? They are fine, but B is more suitable. B is more suitable, right? That is the lowest point. Lowest point of path තමයි. මෙතන path එකේ lowest point එක. This is also lowest point. මේ දෙකම හරි. C is not going to work because the bob is covering the locating pin. Cover and E is also not suitable. The reason is even though E is at the line of the lowest point, E is not so suitable because that is not close enough. And then we are going to make parallax errors. Parallax errors කියන එක දන්නවනේ අපිට හරියට පේන්නේ අර මෙයා මෙතනින් පාස් වෙන පොයින්ට් එක මෙහෙම තියෙද්දි පේන්නේ නැහැ නේ ඊට වඩා මෙහෙම තියෙද්දි පේනවා. That is called parallax errors දන්නවනේ. Parallax errors එනවා. එතකොට ඒ හින්දා ඒකක්වත් හරියන්නේ නැහැ. Only B and D are suitable. Right. Fixing locating pin and take this down. Take it down. And label all points as A, B, C, D, E. And A is not workable, C is not workable, E is not workable. Adish. Right? Again, write down as bullet points. Again, write down as bullet points. First bullet point. Point A is not suitable. Point A is not suitable. First point. Point A is not suitable. Point A is not suitable. Because point A is not suitable because Bob doesn't reach A when it damps over time. Bob doesn't reach A. Bob doesn't reach A when it damps over time. Bob doesn't reach A when it damps over time. Bob doesn't reach A when it damps over time. Second point, second bullet point. B is suitable. B is suitable. B is suitable. As it is a close point to lowest point of path. As it is a close point to lowest point of its path. Next point. C is not suitable. C is not suitable. C is not suitable since it is covered. Since it is covered by the bob as it passes. Since it is covered by the bob as it passes. Since it is covered by the bob as it passes. D is suitable. Right? May දෙකට මම පොඩි ටික්ස් දෙකක් දාන්නම්. B and D are fine. D is suitable. D is suitable. D is suitable for spherical or plum shaped. Plum කියන එක plum shape කියන එක දන්නවද? Plum shaped. For plum shaped bobs. Plum shaped bobs කියන්නේ මොනවද? ඒකද මතක් වුනේ? ඈ? තාම හිනා වෙනවා. ඒකද මතක් වුනේ? Plum shaped bob එක මතක් කරගන්න. මොකද්ද plum shaped bob එකක් කියලා කියන්නේ? What is a plum? Plum කියන්නේ දන්නවද? දන්නවද? plum දන්නේ? මේ සංස්කාර ගාව තියෙන plum එක. ඒක දන්නවද? ළඹය කියලා කියන්නේ. ඒක දන්නවද? ඒකේ plum shape කියලා කියන්නේ නම් ඉතින් අර ළඹය තියෙන එක වගේ නෙමෙයි. මේ තව එක බොක්ස් තියෙනවා. මෙන්න මේ වගේ බොක්ස් තියෙනවා. මේකේ මේ නිකන් අමුතු බොක්ස් තියෙනවද? මේ වගේ ඒවා තියෙනවා. right? ඊට පස්සේ නිකන් මෙන්න මේ වගේ ඒවා තියෙනවා. right? මෙහෙම ඒවා තියෙනවා. they exist. මෙහෙම එකක් යූස් කරනවා නම් මේ පොයින්ට් එක හොඳයි. ඒතර මෙතන මෙයාගේ පොඩි තියෙනවනේ මේ අර මේකක් පොයින්ට් එකක් මේ පොයින්ට් එකක් තියෙනවනේ. එතකොට මේ පොයින්ට් එක යූස් කරන එක ගොඩක් හොඳයි. right? heart shaped වගේ තියෙන බොක්ස් තියෙනවා. right? ඒක තියෙනවා. we don't use මම කියන්නේ එහෙම එකක් ඇහුවොත් if you are given a different shape of a bob and you are asked to think of the locating pin, right? එතකොට මෙහෙම අපිට fix point එකක් වගේ තියෙන බොබ් එකක් දුන්නොත් ඒ fix point එක ගන්න එක lazy. right? දැන් මේකේ මේ උඩ flat surface එකක් ඉඳලා B වගේ කෙනෙක් not that suitable. මේ වගේ කෙනෙක්ට මේ point එකේ තමයි locating pin එක තියන්න ඕනේ. got the point? right? okay, plum shape කියන ඒවා දැන් නැත්නම් මේක එක shapes තියෙනවා. other than spheres. symmetric shapes නෑ. right? වෙන මෙන්න මේ වගේ shapes ගොඩක් වෙලාවට මෙහෙම ඒවා තමයි plum එකේ තියෙන්නේ. පොඩි point එකක් එක්ක. right? okay. next point. Strings with multiple threads. Multiple threads කියන්නේ මොනවද? ඒ කියන්නේ have you seen nylon වගේ strings එකක් තියෙනවා? nylon එකක් තියෙනවනේ. nylon එකේ දන්නව නේද මේ? ඒ කියන්නේ දැන් nylon string එක තියෙන්නේ මෙන්න මෙහෙම මේ තුනකින්නේ. නොහොම එකක් නේ nylon string එක කියන්නේ මේකේ මේවා තුනක් තියෙනවනේ. right? ඔය තියෙන්නේ සරුංගලයක් දිහම ගන්න nylon string එක. මේ nylon එකේ threads ගොඩක් තියෙනවා. ඒතර ඒක ඇත්තටම හදලා තියෙන්නේ මේ මෙහෙම අර rotate කරගෙන හදලා තියෙන්නේ. එතකොට බොබ් එක දාපු ගමන් ඕකත් rotate වෙනවා. අර වෙලා නැද්ද සරුංගලයක්දී කොච්චර කරත් ඒක කැරගෙනවා. නූල අර කොච්චර අපි ඒ කියන්නේ අර මැෂින් කට් එකෙන් අරගෙන මැෂින් කට් එක කියන්නේ once you buy it from the shop, right? ඒක මැෂින් එකෙන් ඕක ඔතලා තියෙන්නේ. හැබැයි අපි එකපාරක් යවලා පස්සේ අපි ඕක ඔතද්දි ඕක හැඹරෙනවා. සරුංගලයවල නැහැ. හරි? මේ normal මේ general things එහෙම වෙනවා. ඒතර nylon ඒවා use කරන්නේ නැහැ. මේ එක මේ thread එකක් විතරක් තියෙන string එකක් තමයි ගන්න ඕනේ. threads ගොඩක් තියෙනවා කියන්නේ ඒක මෙහෙම අඹරලානේ තියෙන්නේ. ඒතර ඒක ආයෙ ඔයා තනකින් මේ ගැට ගැහුවට පස්සේ ආයෙ ඕක හැඹරෙන්න පුළුවන්. there's a possibility. ඒ කියන්නේ බම්බරේ වගේ මෙහෙම කරගෙන නැහැ. පොඩ්ඩක් අරගෙනවා. right? okay. මොකද මම කිව්වේ? A string with multiple threads are not used. Strings with multiple threads are not used. Right. Strings with multiple threads are not used. Strings with multiple threads are not used. Within brackets, nylon strings. So if you haven't seen nylon strings, go to hardware tomorrow and ask for a nylon rope. එතකොට බලන්න පුළුවන් ඒ rope එක ඇතුලේ strings තව ගොඩක් තියෙනවා. nylon ropes තියෙනවා. දන්නවනේ? Strings with multiple threads are not used. Within brackets, nylon strings. As there's a possibility of rotating. Next point. A metallic bob. මම කලින් උත්තර මෙන්ෂන් කරා. A metallic bob is preferred. Since it oscillates for a longer period. Due to less inertia. What is inertia? What is inertia again? Definitions, what's your thought? Inertia. What is inertia? Online? Inertia. What is inertia? Inertia. Huh? What is inertia? Yeah. That is the reluctance to change the state of an object. Is called inertia. Objects which are moving are always trying to keep moving. An object which is at rest tries to keep at rest. Right? That reluctance is called inertia. Right? Now, if I compare this with metal and wood, metallic bob and a wooden bob, when mass increases, inertia increases or decreases? When mass increases, inertia increases. Right? That reluctance increases. Reluctance increases, it keeps the state. Right? Last paper again, 27 paper again. Inertia question 27 paper again question. Right? Just know that inertia varies with mass. Right? Varies with mass, even if the same size. So let's say you have two bobs. One is metal made of iron or something, right? Iron or steel, let's say steel or something, and a bob of same size made of wood, right? Which comes to rest, which comes to the rest faster in a quick time, wood or metal? Obviously wood. That is because of wood is less in mass. Less in mass means less in inertia, right? So it comes to the rest quickly. So the wood accused 25 oscillations, okay, right? It stops before doing 25 oscillations. It stops. It is coming to a stop before 25 oscillations. Therefore, it is not going to work with our thing, no? It's not going to work with our thing. So we are using metallic ones, right? Inertia inertia is the reluctance to change the state, a present state. Reluctance to change the present state of an object. Right? So objects at rest, rest again. But once it starts motion, then they will keep moving. Right? Objects at motion tries to keep moving, and objects at rest tries to keep at rest. Inertia. Right? Again, the moment of inertia again in rotational motion. Right? That property is called inertia. The point Next point. A spherical bob is more suitable. 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 Class Dan nih Pak, udah jadi gitu kalau gue ngerti ya. Mau nih gini. Baik aja nah ulan. Nah tambah ya kenapa Dan no? Spherical bob is more suitable because air drag within brackets air resistance is comparatively low. Air drag is comparatively low. Right? Because shape pegging right? Then box එකක් වගේ use කරොත් එහෙම air drag එක ගොඩක්ම වැඩි. Right? මේ ඔක්කොම air flow එක මෙතනින් අර cut off වෙලා යනවනේ. දැන් මේකේ air flow එකට පොඩි මෙහෙම යන්න පුළුවන් path එකක් තියෙනවනේ. So therefore spherical shape is more suitable. අර streamline shapes වගේ තව හොඳ ඒවා තියෙනවා. හරි? මෙහෙම එකකට ගියොත් වෙන ප්‍රශ්න තියෙනවා. ඒ නිසා දැන් under laboratory conditions this is the most suitable shape. Right? නැතර streamline shapes ඉන්ට වඩා හොඳ ඒවා තියෙනවා. හැබැයි මේ වැඩේට අපි lab එකේ ඉගෙන කරන්නේ. So under school laboratory this is the most suitable shape. Right? Right. And one more thing, listen. When we start the stopwatch, listen. When you start the stopwatch, look at the board. when you start the stopwatch, right? First you have to get familiar with this rhythm of the oscillation. No? මුලින්ම එකපාරට කරපුවාම oscillation එකේ rhythm එක අපිට තේරෙන්නේ නැහැ. For that we are using a small trick. Trick is this. First, you are releasing the bob from here, right? Somewhere here, and let it oscillate. And you are going to count down as 5, 4, 3, 2, 1 likewise, and you are going to count 0. Right? 3 වලින් වගේ start කරත් ප්‍රශ්නයක් නැහැ. Right? දැන් මේක oscillate කරනවා බලන්න. Now this releases, and then මේක release කරනවා 1 මේ 1 මෙතෙන්ට ආව 1 2 sorry 3 2 1, and then the 0 comes down. At 0 you can turn on the stopwatch, because after seeing 3-4 oscillations we can get an idea about the rhythm of the oscillation. එකපාරම තේරෙන්නේ නැහැ මොකද්ද මේ oscillation එක යන විදිය කියලා. පොඩ්ඩක් කියලා බලන් හිටියම ඔගේ idea එක එනවනේ. ආයෙත් දෙන්න. Right. Look at here. මෙන්න මෙහෙම එකක්. This is at the initial point only. Initial point only. To get the exact rhythm of this oscillation. See? දැන් මෙහෙම අපි release කරනවා. Right? Release කරපුවාම දැන් 1 කියලා stopwatch එක දාන්න බෑ. ඒතර අනිවාර්යෙන් delay එකක් තියෙනවා. So therefore what we are doing is you let this go and 3 2 1 කියලා මේ count down එකක් එනවා. count down එකක් ඇවිල්ලා 0 වලදී තමයි start කරනවා. Right? 5 වලින් වගේ ආවත් ප්‍රශ්නයක් නැහැ. minimum 3 වත් එන්න ඕනේ. minimum 3 මේ වගේ නේ. මෙතනින් පටන් ගත්තා. මෙතන ඉඳන් මෙයා මෙතෙන්ට කියලා once this travels to the amplitude, opposite amplitude, and comes to the same amplitude, only one oscillation is completed. No? तर මෙන්න මෙහෙම එකක්. 3 2 1 0. This is where you start the stopwatch. ඊට පස්සේ 1 2 3 4 up to 25. Right? නැත්නම් අර starting point එකේ ඔයාලට lag එකක් එනවා. delay එකක් කියලා lag එකක් එනවා. Right? You will make a lag when turning on the stopwatch. Right? So therefore that's a precaution followed. That's a precaution followed. Right? Write down last point. Last point. Write down. To start stopwatch. To start stopwatch. Start counting with a countdown as 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 3 2 1 0 1 2 3 up to 25. Mention this. 3 2 1 0 1 2 3 up to 25. Right? Listen. Okay, now let's go through what is given here. Right? Quickly. මොනවා හරි තව මිස් වුණාද කියලා බලන්න. මේක නිකන් go through කරලා බලමු. And the past ever questions which have been come from the experiment is mentioned at the last page of the tutor. Questions එක තියෙන්නේ. ඒක mention කරලා තියෙන්නේ ඉතින්. මේ paper එක තොර බලන්න පුළුවන්. Quickly නිකන් go through කරලා බලන්න. Determination of acceleration due to gravity, a simple pendulum, meter ruler. හරි මේ මේට වඩා මගේ list එකේ තිබ්බා. හරි. ඒ මං කියෝ list එක පාඩම් කරගන්න. මොනවා හරි මිස් වෙලා තියෙනවද කියලා දෙනවා බලන්න. Method. Pass the pendulum string through the cork and suspend the pendulum from first hand. Measure the oscillating length L of the pendulum from the point of suspension down to the center of the pendulum. Center of gravity. Right? Note down the value of L and fix the locating pin vertically below and close to the lowest point of the path of pendulum bob. Pull the bob aside till the incline by an angle vertical 5 or 6. Release the pendulum. Start by 40. ඒකත් මම කියවනේ 6 recordings. Table එක තියෙනවා. Right? Considering the value of G into 9.78, find the percentage of the okay. Right, මේ 3 2 1 එක මේකේ තියෙනවා. In order to activate this stopwatch, when the pendulum bob passes the locating pin, start counting in the descending order. Start counting from 3 when bob passes. Sorry, I explain that. That's all. Right. And listen. Listen. And there is another thing that we can do from this same experiment, same setup. Right? This same setup can be extended to find height to the ceiling from the floor. एक question සමහරට ඔයගොල්ලන්ට හම්බුලා ඇති. කළා දෙනවා. Right? එදා පෙපරේ තිබ්බා. Right? එදා පෙපරේ තිබ්බා. ඊට ඩිස්කෂන් එකට දීලා පෙපර් එකේ තියලා. Right? ඉතින් මේක එක්ස්ටෙන්ඩ් කරන්න පුළුවන්. ඒකත් මෙහෙම කියලා දෙන්න නැත්නම් අපරාධෙනේ. සමහර ඉස්කෝලේ කරලා තියෙනවද දන්නවද? See, this is something we can do further. Right? මෙන්න මෙහෙම වැඩක් කරන්න පුළුවන්. Look at the board. Right down below. This same experiment can be extended to this same experiment can be extended. This same experiment can be extended. This same experiment can be extended to find height to ceiling from floor. To find height to ceiling. To find height to ceiling. To find height to ceiling from floor. Right. දැන් pendulum එකක් use කරන්න height to ceiling ගන්න ඕනේ from here to here. Pendulum එකක් use කරේ නැත්නම් කොහොමද ගන්න පුළුවන්? So if you are not using a pendulum to find the height from the floor to ceiling of a building, what are the other methods you have? Can you do it using a meter ruler? Right? Not that accurate. A tape? Possible. හැබැයි tape එක හරියටම vertical ද කියලා අපිට කියන්න බෑ. But even though you are using a tape, right? We can't make sure that the tape is exactly vertical. Roughly ගන්න පුළුවන්. Right? So that's why to get more accuracy, this kind of a method is used. Right? Make it right. Listen. The bob is attached to the ceiling like this. With the cork, everything is there. And cork with the cork, everything is there. Attached to the ceiling. Right? And now you have to take it down somewhere up to some level which is close to floor. Right? අල්ලන්න බැරි තරම් උඩින් මේක attach කරගෙන ඉතින් කරන්න බෑනේ. Right? අල්ලන්න බැරි තරම් උඩින් attach කරගෙන ගන්න බෑනේ. So you have to take it somewhere close to you. Right? From the ceiling. And let's consider height from floor to ceiling as capital H. Right? And height from floor to height from floor to bob as simple h. Right? Simple h කියලා ගමු. Now you can rewrite the equation using these two terms by substituting L and repeat the experiment. Now in this scenario, this is going to change like this. Look at the board. T equals 2 pi root L over G. Now instead of L, right? Make an L. Instead of L, you can write H minus H over G. Right? Then T squared equals 4 pi squared over G H minus H. Right? See? I put this question in the last paper and I went through few answers and I didn't see anyone who has done it in the exact proper way. Right? Variables වල වැරදි තිබ්බම papers තුනක් විතර නිකන් බැලුවා. බලමු. Right? And see, T squared equals, this is 4 pi squared H over G minus 4 pi squared simple H over G. Now tell me, what are we going to choose as the independent variable? What should we choose? Capital H or simple H? Huh? Can you change the distance between floor and the ceiling? right? Make a change. Now, once you adjust the length of the string, simple H changes, right? There's no L in this story, right? You have rewritten L using H and H, simple H and capital H, right? Now, when length of the bob changes, length of the pendulum changes, simple H changes. So manually, what you can change is simple H, right? This whole term is a constant. 4 5 squared HOG is a constant, right? Then this is X. Whatever it is as a product with independent variable is gradient minus, and this is a constant intercept, and this is Y. So what you are going to get is Y equals C minus mx graph. හැමෝම ඇදලා තිබ්බ mx. හැමෝම කියනවා තුනක් විතර දැක්කේ. හැමෝම ඇදලා තිබ්බ mx. h minus h කියන්නේ h minus h එකට variable එක අරගෙන. Capital H is not a variable. Alright. Now what you are going to get is this t squared with h minus mx plus c. මේ minus mx plus c that is a standard curve. Minus mx plus c. හරිනේ? මේක මෙහෙම පේන්නේ නැත්නම් ඉතින් මෙහෙම ලියාගෙන y equals minus mx plus c. That is a standard curve. Plus c minus mx. Something like this. හරිනේ? මේක තමයි curve එක. මේක තමයි curve එක. Now once this curve is plotted, you know gradient and intercept. Gradient of this graph is 4 5 squared over g. Intercept of the graph is, look at here, last part, intercept of the graph here, 4 5 squared capital H over g. Right? Now tell me, what is the easiest way to find capital H? What is the easiest way to find capital H? Now, using the graph. Quickly. Practicals කරන්න. What is the easiest way to find capital H? මම කියලා දෙනවා paper discussions වලත්. What is the easiest way to find capital H now? Huh? Using intercept the. Huh? Using intercept. Online? Who says using intercept? Just using intercept. Again, the point up there. Have certain experiments got make a not only today, throughout. What's the easiest way? Easiest and the best way, actually. Easiest, the best way to find capital H. Any idea? No? No? Yeah? Yeah. No. Possibly. No. I have told you, right? Maybe once or twice. First tell me whether is it determinable using intercept? Intercept එක use කරලා මට capital H හොයන්න පුළුවන්ද? පුළුවන්ද බැරිද? කතා කරන්න ඕනේ. පුළුවන්ද බැරිද? කතා කරේ නැත්නම් මේකෙන් දෙනවා පාරක්. ඔය නෑ නෝ තෙන්ට යන්න පුළුවන්. Tell me, can we find, listen, can we find capital H just by using intercept? Can or can't? පුළුවන්ද බැරිද? එච්චරයි. ඇයි බැරි? පුළුවන්. ඇයි බැරි? ඉතින් graph එක තියෙනවනේ. Graph එක තියෙනවා නම් don't you know the intercept of the graph? We know. ඉතින් බෑ කියන්නේ. පුළුවන්නේ. පුළුවන්ද බැරිද? පුළුවන් නේ ඉතින් පුළුවන් කියලා කිව්වනේ. Right? Now if the graph is there, listen, make a good point. If the graph is there, you know the intercept. Intercept එක දන්නවා. මේක use කරලා කරන්න පුළුවන්. But we don't do. Because there's a safe method, because 4 5 squared over g is common, right? If you divide intercept by gradient, only h remains, no? And now we are totally safe. ඉතින් කියන්න ඕනේ. right? ඒක දැනගෙන හිටියද? දැනගෙන හිටියේ? right? Now we are safe. දැන් මේ 5 squared g මේවා එක ඩීල් කරන්න ඕනේ නැහැ. right? Because c and m are kind of very trustworthy values because of the graph. ඒතොර ඒවා ෂුවර්නේ. දැන් මේ 5 වගේ කෙනෙක් ආව බොරුවට සබ්ස්ටිටියුට් කරන්න ඕනේ නැහැ. Got the point? So in such cases, keep this in mind here onwards, right? You will see the same thing in more coming up experiments. Not only today, right? Current electricity වල එහෙම ගොඩක් ඒවා තියෙනවා. thermal වලත් තියෙනවා. ගොඩක් ඒවා තියෙනවා. Right? Check both, and if you can find it using gradient and intercept with the division or multiplication, our first priority is that. මේකට යන්නේ නැහැ. මේකට යන්නේ නැහැ. First priority is this. Hey, මෙතන error එක ඒතකොට කෙලින්ම නැහැ. We don't need to worry about 4 5 squared over g. Right? Okay. Let's say මේ දෙක ලියලා and h equals c over m. So like this, you can find the height to ceiling from the floor. Right? This is an extension of the same experiment. Right? හරි. ඔයිට වඩා මොකුත් නැහැ ඔය experiment එක ගැන. Take it down. What about you? You want? Okay, take it down. This is it. Take it down. Take it down. This experiment has taken 2 hours. නෑ මේමයි ගයිඩ් එකේ තියෙන විදිහට මට කරන්න පුළුවන් 15 minutes වලින්. එහෙම කළා වැඩක් නෑ ඉතින්. ප්‍රශ්නයක ලියන්න බෑ ඔයගොල්ලන්ට. right? ඔව් නිකන් බලන්න ගයිඩ් එක මොකක්ද දීලා තියෙන්නේ කියලා. හැබැයි questions වලට ඒක එන්නේ නෑ. Because guide is for, I mean, reference. Right? There is a more depth compared to that. ඒක තියෙන ටික පුළුවන් වුණා කියන එක නෙමෙයි වැඩේ. Basics is there. I mean, basic is in the guide. But this is what you should know about this whole thing. දෙකට නම් ඉවර ගන්න බැරි වෙයි. Where are you from? Yeah. Huh? Close by. Or not good? How is it? It can know. It can know. That's Adisha?